around us. We have companies that helping cancer treatment, and they use the platform, and you see how they advance their research and how they manage to overcome all their own expectation with explainability they manage to extract from the platform, together with other companies that running on autonomous vehicle. And you get the feel that you're part of their project, right? They're sharing with us the result, they're sharing with us the incredible use cases and insights they manage to get. And you feel so, giving you this sense of duty and purpose.
Welcome to 20-Minute Leaders. Just sit back, relax, and learn from the leaders of today. It's a journey. Each one is different, unique, inspiring. Let's get started. 20-Minute Leaders is a proud supporter of Make-A-Wish Israel and Tech to Peace, and is in proud collaboration with Secret Chord Ventures, J Ventures, Riverside FM, Fusion VC, Birthright Excel, J Impact, Leap, Google for Startups, and Hippo, and in media partnership with CTech. Hello, and welcome to another awesome episode of 20-Minute Leaders. I'm really excited about this one. This is a company that I'm personally invested in, but the story is so cool about how they use deep learning to meaningfully impact research teams. Of course, I'm objectively biased, but I still think this is such a cool company. And specifically, we're going to be talking to Yotam Azriel, the Chief Technology Officer. Yotam is an expert in machine and deep learning with 10 years of experience in these fields. He's been involved in massive military projects in the field of underground warfare and later on joined Soreq Nuclear Research Center as a key developer in machine learning projects. Following his army service, Yotam developed and led AI and big data projects from research to production for a few startups and acted as a professional consultant to companies developing AI technologies. His expertise includes image and video recognition, NLP, Algo-trading, and signal analysis. Yotam is an autodidact with strong leadership qualities and great communication skills. Yotam Azriel, welcome to 20-Minute Leaders. Thank you very, very much for being here. How are you?
I'm great. Thank you for having me. It looks like an amazing project. I look forward to get here with you.
I appreciate that very, very much. Yotam, we've known each other for a while. I'm personally also invested in the company that you're helping run, TensorLeap, looking at deep learning. But while this conversation will also have components of TensorLeap inside, what I'm really curious about is to hear your own journey and to hear some of the bigger pain points that you've identified in the research arena. And, we're all aware that machine learning and deep learning tools are taking over the world by storm. If software was eating the world, then AI is really transforming it in unprecedented ways. And the process and the progress to create a lot of these models and to fine-tune them is not that trivial. And that's exactly the space that you're coming in. And so obviously the work that you've dedicated yourself to lends itself to have a dramatic impact on organizations that later on make a large impact later on. So that's enough from me. But Yotam, tell me a little bit about yourself and some of the things that you're really excited about.
Oh, myself. Well, I started my journey in science way back, like 10, 12 years ago, in a very small desert city in the south of Israel. I started around physics. I got familiar with the science area after some inspiring school teacher got me into some open lectures in the Ben-Gurion University. I got there the first time I saw some professor lecturing about his own research, and I understood that it's gonna be. I saw how inspired you were towards the research you've been.
Yeah. So going back to a little bit about, your upbringing and what got you so excited about this space.
About the space of neural networks. Well, this neural network space is amazing. You can see the things that people doing with it. We're pushing the limits of what's possible every day a bit more. And, the sense of responsibility and duty is so visible when you're doing stuff with neural network. Now, I started my journey long time ago, like around machine learning classic and physics about 10 years ago, a bit before the army. I started to work for some small startup company called power math, something I led the research around physics there. And I started there as a mathematician, a physicist who started to simulate the physical rules in order to improve some electricity transfer platforms. From there, I joined to the army to help with underground tunnels detection research. So, and in the army, we did some more advanced techniques than simply simulating the physics around us. We started to use some machine learning. So you could see how people became a bit less of domain expert because they used to, they needed only to understand which feature were matter and which feature less, and doesn't need it to completely simulate the whole physics around them. After the army, I joined the Nuclear Research Center for...
As one does after the army.
Yeah, as one does after the army. Well, in Israel, it's possible. My working around the underground tunnels detection got some attentions. So yeah, I joined this Nuclear Research Center, and we started I started to be busy with unstructured data, which is a bit different problem than everything else, right? You don't familiar with all the features that constructing some space. You have to understand how to extract this information.
Right.
And this is the first time I heard about those neural networks, which is a whole process that is essentially a feature extractory model that allow you to apply deep mathematics models on some unstructured data.
What was it about neural networks that, obviously you're a researcher, you're passionate about physics and mathematics and the space. But, as you're going through your journey, obviously you're identifying things that you're more or less excited about. And it sounds to me like something about this unstructured nature of this work and neural networks really got you hooked. Well, what was it about this space that got you so excited?
Yeah, it's the applications. Like in the end of the process, when you want to solve genetic sequencing problems and you want to find mutations in data that you have no idea how to access to, the only way you can do it is with neural networks. Or when you want to solve autonomous vehicle or text generation or everything that is, used to be impossible till neural networks. We just enable all those different technologies. So, as you know, from the side of scientists, eventually, out of nowhere, you can be busy with a very deep problems. You can solve stuff that weren't solvable until then. On top of all it.
And so, what was it exciting to you from a mathematics point of view, or from a world-changing point of view? The fact that you can now apply this to a variety of applications that previously were not attainable until now.
Well, the answer is both. The math behind it's amazing. Like the people that work on those fields are brilliant, and the ideas and, all this research is just incredible. I used to have a habit to read at least one paper every morning. And then so I used to
every morning.
And yeah, the best thing I could do for myself. So the math is amazing and the application is incredible and your impact is huge. So just exciting every day when you get to work on those stuff.
Incredible. Tell me a little bit about the transition to the startup world. So you're working for organizations, and a few years ago you decided to go on your own journey. What was it about sort of this mission behind that, the mission that TensorLeap is on, that got you really excited?
Yeah. When you're working within all those different development teams and developing those cutting edge technologies, you get in a different perspective. And the way we used to develop machine learning and AI kind of required a changing. In the beginning, 2014, You could train 100 model in 10 minutes and research the model that is working best for each point. You could tear apart each model to 100 pieces, understand completely how it works. If something failed, you could work a bit and explain why it failed. Now, the neural network, they enable so much, but they're so complex and so big that it became so hard to understand how they're working, and therefore so hard to adapt those technologies. Now you see a technology that can transform the whole world, can solve, can get us much forward with neural net, with cancer detection, with cancer treatment, with autonomous vehicle, and still it's impossible to adapt it because companies don't have the confidence that's required in order to deploy it to production. Because it's impossible to test today neural network. They're huge. The neural network today applying on fields that has too many edge cases, and each edge cases doesn't get enough representation in this test set that everyone managed to build. So they're building like 500,000 samples test set, and each edge case may be represented by a few hundred or thousands of samples. They will never move the accuracy enough in order to show the data scientists that it's failed. So you get in a very hard time getting confidence on what you're going to deploy to production or explain how it works. So once it's getting to production, getting some prediction outside and your users trying to ask, okay, so why you think that this is the result? It's going to be a huge problem to explain how it happened. So
right. So what you're describing here is sort of this paradigm in which we have a very unique opportunity that neural networks present to us, but the lack of explainability and observability into understanding why something is as it is. There's only so much trust there can be, and obviously as you get to the more fine-grained question of why did something behave the way that this specific element behaved, then it's getting a little bit more difficult and complex to solve. So is that really did I catch really the main pain point that you're describing here?
Yeah, so you have two kinds of explainabilities. You have a local explainability, which is trying to explain why neural network took decision in a specific place. Like, for example, why Tesla car crashed on the truck that looks like a bridge. It's a local, it's a very specific example. And you have global explainability when you're trying to explain how neural network perceives reality in general, like which cases looks alike and what dimension distributing the data sets and etc. So we're trying to solve both. We have a very unique technology that's able to extract the most relevant information that the neural network managed to learn in the training process and distribute the whole data set according to that, which allow us to find all the small use cases that counted as edge case because they're represented by very specific features that not that common, for example. So,
So give me, maybe this can be better explained through some specific examples of how different problems in the world may benefit from sort of this a solution to this pain point that you're describing. So what are some ideas for case studies that this would be relevant for?
Yeah, it's also one of the reasons it's so exciting to found TensorLeap. You can see around us, we have companies that helping cancer treatment. And they use the platform, and you see how they advanced their research and how they managed to overcome all their own expectation with explainability they managed to extract from the platform, together with other companies that running on autonomous vehicle. And you get the feel that you're part of their project, right? They're sharing with us the result, they're sharing with us the incredible use cases and insights they managed to get. And you feel so, giving you this sense of duty and purpose, which is amazing. So
what is their interaction with, so maybe you can share with me about, what is sort of their research pipeline, and where does TensorLeap interject into the pipeline of the work that let's say this cancer treatment company, how does TensorLeap integrate into a pipeline like that?
Sure. So they have a team of data scientists. This team of data scientists need to collect enough of data sets in order to, in their case, detect very particular mutations of cancer using liquid biopsy. So in liquid biopsy, you have a lot of dead cells in the blood. Some of them belong to cancer, and it's a very few, some of them, like 0.1%. It's very hard to detect it when you get in billion of reads, billion of different gene sequences that you need to process. So what they do, they need to understand how to construct these data sets from the right amount of gene sequences. Now, unlike images and voice and text, stuff that people like us are used to process, it's a black box for them. They have no idea which sample looks like another. Like this gene of sequences looks in a very particular way, and another gene sequences looks in a different way. But are they similar? We don't know. We can't see it with our eyes. So what they able to do is once the training a neural network, that finding the features that relevant to understand which samples look like each other, they able to understand how their data set is distributed and what kind of samples they're missing and what kind of samples they have too much of. And sometimes they collecting these data sets, starting randomly and constructing some kind of neural network that should be able to extract the information from those sequences, given it the task of detecting mutations, very specific mutations that they know how to treat. And after the first training of the neural network, TensorLeap extracting within the development process, right? All the different features that distributing the data set in this or other way and notifying the data scientist about edge cases that it found using the features that land within the model itself. And by that, they detected, for example, a list of bugs they had in their own data generation pipeline. So they have a lab and the sequencing lab tests, and they detected that they had a bug in a few areas that caused a very big bias in this neural network. Now, they will never have any ability to detect those stuff without applying very deep explainability techniques to analyze the features that land within this neural network. So we're sitting in those areas where data scientists trying to improve these development cycles, which is constructing the data set, error analysis, and generating different experiments to solve very specific issues, and with testing. So before each time they need to deploy a new model to production, they need to know if it's really solved several issues and that none of the new issues emerge into this new model. So
take me back to how everything you just described about, about the way that you're empowering researchers and data scientists within these organizations do their better work. How does this tie into your own journey and what you care about? You started off by talking about how excited you are, both on the mathematics, but the application layers of what all this research is doing. Going on to founding TensorLeap, how does this feed into your own sort of mission in life right now of what you care about in the advancement of research and the applications?
A bit before I founded TensorLeap together with my partners, David and Nir, I worked with David in autonomous vehicle company, and we developed those technologies, and it was hard. We needed to detect obstacles using passive sensors 2 kilometers from the target, on dark, on fog, on snow, with camera that's moving like crazy. So we applied, list of pipeline of neural network that was super advanced. And each time it got to production, it got to one of our clients, it came back with, okay, it works perfect, except of this and these days when we think that the sun were in some area in the sky. I don't know. Now I need to take it all, conduct experiments for months, hope that I guessed right, and give my client confidence to use it again when I myself terrified that it's going to fail. I'm applying neural network on autonomous vehicle. I might kill people. And you don't feel good with yourself when you're doing that, right? You don't have a lot of choice. You get paid and you're doing, we did the best we could. We did the best there is outside, right? We used the cutting edge technology. I read every day a paper or two. I did everything we could. No one did better than us in any benchmark, but still, when I deployed a model, I couldn't sleep. It was terrible. And it's just so hard to get confidence on the thing that matter when you have no visibility towards how it's taking decisions, right? Now, David used to come to me and tell me, Yotam, is it really nothing to do? Like, this is the reality that we need to accept? And the answer is no. I told him, no, of course not. But if you'll give me, let's say 5 or 10 full stacks and 1.5 years, I'll manage to build some mechanism that will allow us to extract the features and the information we need in order to query these neural networks. And after it happened for 6 months or a year, we decided to found TensorLeap. And that company using it today.
I love it. That is so cool, Yotam. And I think that I just want to constantly bring it back to sort of this underlying mission. You know, TensorLeap is fantastic. As an angel investor, obviously, I'm very objective in me saying that it's a fantastic company. But you know, I think the truth is that what you're touching on is a problem that we all need to be cognizant of, and it's something that we all need to appreciate and respond to. This underlying question, fundamentally, of how do we do research and how do we advance technology? And this is not, you know, child's play. We're not building these next games that are just entertainment. And, you know, these are literally life-altering technologies, whether it be cancer research to save lives, or whether it be different medicines to be administered to people and researching the side effects, or autonomous cars that, yes, they're going to be taking over the world, and hopefully the right networks are being used to train them. And so I think that what you're doing here above all is making sure that we have a safer future, more resilient future with obviously better results and more efficient research, but underlyingly one that we control better because we want to do good in the world. Whoever's helping train the next neural network system for autonomous cars, having that ability and observability and explainability will make it safer for all of us. And Yotam, I really want to appreciate you for this time and the energy, for the great work you're doing for TensorLeap, but more importantly for sharing this exact message that hopefully it got right, because it's a very inspiring one. So thank you very much.
Thank you. Thank you, Michael. It was great to be hosted by this. Yeah.
Thank you.